ವೇವ್ ಥಿಯರಿನ ಫಸ್ಟ್ ಯಾರು ನಮಗೆ ಫ್ರೇಮ್ ಮಾಡಿಕೊಡ್ತಾರೆ? ಕ್ರಿಶ್ಚಿಯನ್ ಹೈಗನ್. ಡೆತ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್. ಡಯಾಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂದ್ರೆ ಆ ಮೆಟೀರಿಯಲ್ಗಳಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಇರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಡಿ ಫಾರ್ ಡೆತ್, ಡಿ ಫಾರ್ diamagnetism. Induction coil works on the principle of mutual induction. The next question, students. The question says, the apparent frequency. ಗಮನಿಸಿ ಅಲ್ಲಿ, ಟ್ರೂ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಲ್ಲ, ಅಪ್ಯಾರೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಅಪ್ಯಾರೆಂಟ್ ಅಂದ್ರೇನು? ನಮಗ್ ಕೇಳಿಸುತ್ತೆ ಆದ್ರೆ ಅದು ನಿಜವಾದದ್ದಲ್ಲ. ಫಾಲ್ಸ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ದ ಅಪ್ಯಾರೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಅ ನೋಟ್ ಈಸ್ 200 hertz. ಯಾವಾಗ? when a listener is moving with a velocity of 40 meters per second towards a stationary source. In the first case, the listener is moving towards a stationary source with a speed of 40 meters per second. When he moves away from the same source with the same speed, the apparent frequency of the same note is 160 hertz. In the second case, he is moving away from the same source with the same speed. Now, the apparent frequency is 160 hertz. I have to calculate the velocity of sound in air. Here two situations are given. In the first situation, the listener or the observer is moving towards a stationary source. And in the second case, ಏನಾಗ್ತಿದೆ? The observer is moving away from the stationary source with the same speed, and the apparent frequency changes. I have to calculate velocity of sound in air. First case, I assume that the listener is moving towards the stationary source. Clear ಆಗಿ ಹೇಳಿದಾರಲ್ವಾ? Stationary source. So listener moves towards stationary source. What is the expression for apparent frequency here? We have studied that. Doppler effect na ನೆನಪಿಸ್ಕೊಳ್ಳಿ. F dash is equal to V plus V naught divided by V into F. F dash ಅಂದ್ರೆ ಏನು? ಅದೇ apparent frequency. V ಅಂದ್ರೆ ಏನು? ವೆಲಾಸಿಟಿ ಆಫ್ ಸೌಂಡ್ ಇನ್ ಏರ್. ಅದನ್ನೇ ಕಂಡುಹಿಡಿಬೇಕು. V naught, velocity of the observer or listener in this case. F, actual frequency. So what is F dash in the first case? First case apparent frequency is 200 equals V has to be found out. Velocity of the observer is 40 divided by V into F. In the second case, listener moves away from the stationary source. Second case ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ? The listener is moving away from the stationary source with the same speed. In this case, what happens to apparent frequency? F dash is V minus V naught by V into F. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಗಳನ್ನ ನೀವು ತರೋವಾಗಿ ಕಲ್ತ್ಕೊಂಡಿರ್ಬೇಕಾಗತ್ತೆ. What is F dash in the second case? 160 is V minus 40 by V into F. When you equate these two expressions, velocity of sound in air turns out to be 360 meter per second. Nodi, you just know these expressions, substitute very easily. I'm arriving at the answer. Wave theory of light in its original form was first postulated by wave theory na first yaru namage frame ಮಾಡ್ಕೊಡ್ತಾರೆ? Christian Huygens. Corpuscular theory of light na Sir Isaac Newton. Wave theory na it is Christian Huygens. If a liquid does not wet glass, the angle of contact is obtuse. ನೋಡಿ, ಇವೆಲ್ಲ ಥಿಯರಿಟಿಕಲ್. ಇಲ್ಲಿ ಯಾವುದೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸೋ ಫಾರ್ಮ್ಯುಲಾಸೋ ಇಲ್ಲ. If you place a drop of liquid on a glass and the liquid is not wetting the glass in wet ಮಾಡ್ತಿಲ್ಲ, then the angle of contact between them is always obtuse. The next problem. The magnitude of the current I in unit called ampere has to be calculated. The value of this I. If you clearly observe the circuit, 1 ampere current is entering the circuit and 1 ampere current is coming out of the circuit. Alva? 1 ampere circuit enter ಆಗ್ತಿದೆ, 1 ampere circuit ಅಲ್ಲಿ ಹೊರಗಡೆ ಬರ್ತಿದೆ. So the main current that flows through the circuit is 1 ampere. Now, if you observe 15 ohm and 5 ohm are in series. You'll observe ಮಾಡಿ ಮಕ್ಕಳೇ ಒಂಚೂರು. 15 ohm, 5 ohm are in series. So here the effective resistance is 20. Series alide. R1 plus R2. 15 plus 5, 20. This 20 and 10 are in parallel. So, RP is 20 into 10 divided by 20 plus 10. 200 divided by 30. Nearly 6 ohms ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ. So the effective resistance when 20 ohms and 10 ohms are connected in parallel is nearly 6 ohms. So now I write this circuit as, so here I have 60 ohm, 6 ohm, main current is 1 ampere. I say this is I1, this is I2. I1 has to be calculated current flowing through 60 ohm resistor. How will I calculate parallel combination of resistors? Branch current formula, very simple. So I1 is main current into resistance of the other branch. ಸಾವಿರ ಸರಿ ಈ ಫಾರ್ಮುಲಾನ ಉಪಯೋಗಿಸಿದ್ದೀನಿ. Main current into resistance of the other branch divided by the sum of the resistances. 60 plus 6. Now, main current is 1. So this is 6 divided by 66. This is 1 by 11, which is nearly 0.1 ampere. Find the equivalent resistance. Condense the circuit. Apply something called branch current formula. Very easily, I am arriving at the answer. Next. An electron of mass m and charge q. So there is an electron whose mass is m and charge is q, traveling with a speed v along a circular path of radius r in a uniform magnetic field of strength b. ಅವ್ರು ಏನ್ ಹೇಳ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ, ಒಂದು ಸರ್ಕ್ಯುಲಾರ್ ಪಾತ್ ಇದೆ, ಆ ಸರ್ಕ್ಯುಲಾರ್ ಪಾತಿನ ರೇಡಿಯಸ್ ನ ಆರ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ of mass m, charge q is traveling along that circular path with the speed v. Strength of the magnetic field is b. Now, if the speed of the electron is doubled and magnetic field strength is halved, ಆ ಎಲೆಕ್ಟ್ರಾನಿನ ಸ್ಪೀಡ್ ಅನ್ನ ಡಬಲ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ನ ಹಾಫ್ ಮಾಡಿದ್ರೆ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ಇಟ್ಸ್ ರೇಡಿಯಸ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಇನ್ ದ ಫಸ್ಟ್ ಕೇಸ್ ವಿ ನೋ ರೇಡಿಯಸ್ ಆಫ್ ದಿ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಇಸ್ mv ಡಿವೈಡೆಡ್ ಬೈ qb. ಇದನ್ನು ಸುಮಾರು ಸರಿ ಬರ್ದಿದ್ದೀವಲ್ವಾ ಮಕ್ಕಳೇ? ರೇಡಿಯಸ್ ಆಫ್ ದ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಇನ್ ವಿಚ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆರ್ ಅ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ರಿವಾಲ್ವ್ಸ್ ಆರ್ ಈಕ್ವಲ್ಸ್ mv ಡಿವೈಡೆಡ್ ಬೈ qb. ನೆಕ್ಸ್ಟ್ ಕೇಸ್ ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ? ಆರ್ ಡ್ಯಾಶ್ ಮಾಸ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಸೇಮ್ ಇರುತ್ತೆ, ಚೇಂಜ್ ಆಗಲ್ಲ, ಅದೇ ಎಲೆಕ್ಟ್ರಾನ್. ಆದ್ರೆ ವೆಲಾಸಿಟಿ ಏನಾಗಿದೆ? ಸ್ಪೀಡ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಡಬಲ್ಡ್, 2v ಆಗೋಯ್ತು. ಎರಡನೇ ಕೇಸಲ್ಲಿ ಸ್ಪೀಡ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಡಬಲ್ಡ್ divided by charge remains the same. magnetic field strength is reduced to half, B divided by 2. ಅಂದ್ರೆ 2 ಮೇಲ್ ಹೋಯ್ತು, ನಮಗೆ mv by qb ಸಿಕ್ತು. 2 ಮೇಲ್ ಹೋಯ್ತು, 2 into 2 is 4. So mv by qb is nothing but r. So this is 4 times r. So the answer is 4r. So radius ಯಾವ ರೀತಿ change ಆಯಿತು? It becomes 4 times the initial radius. See, very beautiful. Now, the potential difference across the internal resistance R1 is equal to the EMF of the battery. Then I have to calculate the external resistance. ಕೊಟ್ಟಿರೋ ಕಂಡೀಷನ್ ಏನು? Potential difference across the internal resistance R1 is equal to what? He says EMF of the battery. ಎರಡು ಸೆಲ್ಗಳನ್ನ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ಫಸ್ಟ್ ಟೋಟಲ್ EMF ಕಂಡಿಡ್ಕೊಳ್ಳೋಣ. ಸೊ ವಿ ವಿಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಟೋಟಲ್ EMF E. The cells are in series. E plus E series ಅಲ್ಲಿದೆ, ಸರಣಿ ಬಂಧನದಲ್ಲಿದೆ. E plus E which is 2E. ಅದೇ ರೀತಿ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಂಡಿಡ್ಕೊಂಡ್ರೆ R becomes equal to this capital R, R1 and R2 are again connected in series. So R plus R1 plus R2. So this is the total EMF. This is the total resistance. And we know the current flowing through the circuit is E divided by R. ಈ ರಿಲೇಶನ್ಶಿಪ್ಸ್ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು, ತರೋವಾಗ ಪಾಠ ಓದ್ಕೊಂಡಿರ್ಬೇಕು. So the main current will be E divided by R, which is 2E divided by R plus R1 plus R2. ಅವ್ರು ಕೊಟ್ಟಿರೋ ಕಂಡೀಷನ್ ಏನು ಲೆಕ್ಕದಲ್ಲಿ? The potential difference across the internal resistance R1 is equal to EMF E. So the EMF E is equal to potential difference across R1. So I R1, this is given potential difference, Ohm's law, I into R. ಅವ್ರು across R1 ಅಂತ ಹೇಳ್ಬಿಟ್ಟಿದ್ದಾರೆ. I into R1 is equal to what? EMF of the battery. So I is equal to E divided by R1. ಇಲ್ಲೊಂದು I ಇದೆ, ಇಲ್ಲೊಂದು I ಇದೆ. ಈಕ್ವೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಸೊ ವಿ ಹ್ಯಾವ್ E divided by R1 is 2E divided by R1 plus R plus R1 plus R2. E ಮತ್ತೆ E ಕ್ಯಾನ್ಸಲ್ ಆಗೋಯ್ತು. So that is, so when you simplify, it turns out to be R1 minus R2. So simplification has to be at a brisk rate. ನೋಡಿ ಇಲ್ಲಿ 2 times R1 minus R1 minus R2 is R. So very clearly, R1 minus R2 is R. So this simplification you need to do at a brisk rate. Now the problem says, by using only two resistance coils singly in series or in parallel, one should be able to obtain resistances 3, 4, 12 and 16 ohms. The separate resistance of the coil are ಒಂದು ಕಾಂಬಿನೇಷನ್ ಉಪಯೋಗಿಸ್ತೀವಿ. Combination of resistors. Either I use the single combination in series or parallel. I should get resistances of 3, 4, 12 and 16 ohms. Then the separate resistance of the coil is, this is mere inspection. You know the expression for resistance and series and parallel, you will arrive. So I'll consider, let R1 be 4 ohms, R2 is 12 ohms. This is only by inspection, trial and error. With this two combination, I am trying to see whether I can get the remaining two resistances. Tappadre innಎರಡು combination different try ಮಾಡೋಣ. So I know RS is 4 plus 12, which is 16 ohms. And RP is 4 into 12 divided by 4 plus 12. So this is 48 by 16, which is 3 ohms. Andre, by using this combination, I am able to get the remaining two resistances. So the value of R1 and R2 has to be 4 and 12. The electrons in the beam of a television move horizontally from south to north. One electron beam ide television alli, they move horizontally from south to north. The vertical component of the Earth's magnetic field points down. The electron is deflected towards. Fleming's left-hand rule. The force acts on the electron beam towards east. Therefore, it has to be deflected towards east. A tangent galvanometer has a reduction factor of 1 ampere. Nenpitkolli, reduction factor, tangent galvanometer. And it is placed with the plane of its coil perpendicular to the magnetic meridian. The plane of the coil is perpendicular to the magnetic meridian. The deflection produced in the TG when a current of 1 ampere is passed through it. Tangent galvanometer concept. Most of you wouldn't have studied this from the new syllabus, but an interesting concept. The current flowing through the tangent galvanometer is given by the expression I equals K tan theta, the current which flows through the TG. K is called reduction factor of the TG. Theta is the deflections produced in the TG. He's asking us for the theta, that's all. So here, tan theta is I divided by K. What is the magnitude of current passed? 1 ampere. K is 1. Tan theta is 1, which clearly means theta is 45 degrees. So the answer is 45 degrees. This is an assignment problem. 2012 session I have solved this. 100 ohms is the answer. This is an assignment for you all again. Continuously previous 3 sessions I have kept on solving. Understand, when I say assignment, make a concise effort to solve this. So 0 will be the answer. Next one. Again, an interesting one. 5 amp current is set up in an external circuit by a 6 voltage source for 6 minutes. Current of 5 ampere is set up in a source using 6 volt battery for 6 minutes. 6 ನಿಮಿಷಕ್ಕೆ 6 ವೋಲ್ಟ್ ಬ್ಯಾಟರಿನ ಉಪಯೋಗಿಸಿದಾಗ 5 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಸಿಗ್ತಿದೆ. Chemical energy of the battery is reduced by Faraday's law. Again from the old syllabus. Chemical energy is V I T. Just remember, chemical energy reduced in a battery due to electrolysis is VIT. So V is 6, I is 5, time interval is 6 minutes, converting into seconds, 10800 joules, or which is nothing but 1.08 into 10 power 4. The answer has to be interesting. Chemical energy. Chemical energy is nothing but EMF. EMF is therefore volts. It cannot be joules. Chemical energy, electrolysis, EMF is generated. EMF is expressed in volts. So the answer is 1.08 into 10 power 4 volt. Now, the current in a simple series circuit is 5 ampere. One circuit alli, when there is some resistance R, the current setup is 5 ampere. When an additional resistance of 2 ohms, R jote additional resistance of 2 ohms connect adre, resistance jasti aitalva, current drops to 4 ampere. The original resistance of the circuit has to be calculated. Andre, initially, he says, andre, modalagi. When there is some resistance R in the circuit, current is 5 ampere. So ನಮಗೆ ಗೊತ್ತು ಓಮ್ಸ್ ಲಾ ಏನು ಹೇಳ್ತು, V is the product of I into R. So I say I is 5 and the resistance is R. Now what happens? Additional resistance of 2 ohms is inserted. So R dash is now R plus 2, so that V becomes I into R dash. So when that additional resistance is inserted, current becomes 4 amperes. So V is 4 R plus 2. This is 4R plus 8. ಇವೆರಡನ್ನ ಈಕ್ವೇಟ್ ಮಾಡಿ. So 5R minus 4R is R. So what is the value of R? So it has to be 8 ohms. I'm just equating these two. When you equate, you get R to be 8 ohms. Again, a simple circuit solving question. We have done this quite number of times. How do you do? R2, R4, R3 parallel allide. So 1 by Rp is 1 by R2 plus 1 by R3 plus 1 by R4. Substitute madi, take the reciprocal, you get so many ohms. That Rp and R1 are in series. So R effective is Rp plus R1. So many ohms. The third option is the answer. Again, an assignment problem on meter bridge. Very simple. 9 will be the answer. Next one. An electric field 1500 volt per meter. Electric field strength ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 1500 volt per meter. And magnetic field 0.4 Weber per meter square. Strength of the electric field is given. Strength of the magnetic field is given. Act on a moving electron. The minimum uniform speed along a straight line the electron can have is beautiful concept. The electron is acted upon by both electric and magnetic field. ಪ್ರಶ್ನೆಯಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ? ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಲೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಪ್ಯಾಕ್ಟ್ ಇದೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಂಪ್ಯಾಕ್ಟ್ ಇದೆ, which means it is deviated from its original path. Because of that electric force and magnetic force, the electron moves away from its original path. But that should not happen. He says the electron has to move in a straight line. It should not deviate from its path. It should not go away from its path. Velocity selector condition. This will happen only when the speed of the electron is the ratio of E divided by B. ಇದನ್ನ velocity selector condition ಅಂತ ಹೇಳ್ತಾರೆ. So 1500 divided by 0.4. ಅದನ್ನ 4 into 10 power minus 1 ಅಂತ ಬರಿತೀನಿ. 1500 by 4 is 375 into minus 1 ಮೇಲ್ ಹೋದ್ರೆ plus 1 ಆಗುತ್ತೆ. So the answer is 3.75 into 10 power 3 meter per second. So that is the speed of the electron to move undeflected in this cross field. In an ammeter, 10% of the main current, only 10% of the main current is passing through the galvanometer. ಬರೀ 10% ಮಾತ್ರ, ಮೇನ್ ಕರೆಂಟಿನ 10% ಮಾತ್ರ ಗ್ಯಾಲ್ವೆನೋಮೀಟರ್ ಮೂಲಕ ಹೋಗ್ತಿದೆ. If the resistance of the galvanometer is G, then what will be the value of shunt resistance? ಮಕ್ಕಳ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಹೇಳಿ shunt resistance ಗೆ. So S is Ig into G divided by I minus Ig. Now only 10% of the main current flows through the galvanometer. So Ig is 0.1 into G. I say I is 1 ampere divided minus 0.1. So this has to be G divided by 9. Only 10% of main current. Main current na 1 ಅನ್ಕೊಂಡ್ರೆ 10% ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು? 0.1. So when you simplify G, this is nearly 0.99. 1 ಅಂತಲೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು. So the answer will be G divided by 9. Among the following properties describing diamagnetism, depth magnetism. ಡಯಾಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂದ್ರೆ ಆ ಮೆಟೀರಿಯಲ್ಗಳಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಇರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. D for depth, D for diamagnetism. Identify the property that is wrongly stated. Diamagnetic material do not have permanent magnetic moment. This is true. Magnetic property is acquired only when there is dipole moment. Diamagnetism, depth magnetism, a material magnetism illa. Why? They do not have permanent magnetic moment. Fine. Diamagnetism is explained in terms of electromagnetic induction. True, ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಬರಬೇಕಾದ್ರೆ ಇಂಡ್ಯೂಸ್ ಮಾಡೋದು ಒಂದೇ ಆಪರ್ಚುನಿಟಿ. Diamagnetic materials have small positive susceptibility. No, such materials always have negative susceptibility. Permeability is very much less than 1. Susceptibility is negative. Magnetic moment of individual electrons neutralize each other. True. So the answer which is wrong, which is not apt for a diamagnetic material, is the third one. Induction coil works on the principle of mutual induction. Square root of the product of inductance L and capacitance C has the dimension of. ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂಡ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ನ ಇಲ್ಲಿರೋ ಯಾವುದಾದ್ರೂ ಕ್ವಾಂಟಿಟಿಗೆ ಹೋಲಿಸಿ ಅದರ ಡೈಮೆನ್ಷನ್ಗೆ ಹೋಲುತ್ತೆ ಅಂತ ನೋಡಬೇಕು. ಗುಡ್. ರೆಸೊನೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಸೊ ಡೆಫಿನಿಷನ್ ಆಫ್ ರೆಸೊನೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಎಫ್ ನಾಟ್ is 1 by 2 pi root LC. 1 by 2 pi has no dimensions. ನಾವು ಹೇಳಿದೀವಿ ಸ್ಕೇಲಾರ್ಸ್ಗೆ ನಂಬರ್ಸ್ ಡೈಮೆನ್ಷನ್ ಬರೆಯಕ್ಕಾಗಲ್ಲ. ಫ್ರೀಕ್ವೆನ್ಸಿನ ಟೈಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದಾ? ಗುಡ್. ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇಸ್ ಟೈಮ್. ಸೊ root LC has the dimensions of time. Principle of homogeneity. ಎಲ್ಲಿ ಎರಡು ಕ್ವಾಂಟಿಟಿಗಳನ್ನ ಈಕ್ವೇಟ್ ಮಾಡ್ತಿದ್ದೀವಿ, where two quantities are equated, added or subtracted, they should have the same dimensions. So here root LC has the dimensions of time.